The earth trembled violently, shaking the very foundations of the land and sending ripples of fear through the hearts of those who felt it. This seismic event occurred in the Caribbean Sea on January 14, 2025, a date that would be etched into the memories of many. A powerful 7.6 magnitude earthquake struck between Honduras and the Cayman Islands, a region known for its beautiful coastlines and vibrant marine life. The quake sent shock waves throughout the region, disturbing the tranquil waters and causing a momentary panic among the coastal communities. While the physical damage was minimal, the earthquake triggered a tsunami advisory, reminding everyone of the latent dangers that lurk beneath the ocean's surface. This event served as a stark reminder of the immense power of seismic activity, a force that can reshape landscapes and alter lives in an instant. It also highlighted the interconnectedness of our planet, showing how an event in one part of the world can have ripple effects far beyond its epicenter. The Caribbean earthquake occurred along the Cayman Trough, a significant underwater geological feature. This is a complex geological feature where the North American and Caribbean tectonic plates converge, creating a zone of intense geological activity. The movement of these massive plates generates immense pressure along the fault line, a pressure that builds up over time. The sudden release of this built-up pressure is what causes earthquakes, unleashing energy that has been stored for years, sometimes even centuries. The Caribbean event underscores a critical point. Fault lines are not isolated phenomena. They are part of a vast interconnected network that spans the globe. These tectonic plates are constantly shifting and grinding against each other, a process that is both natural and essential for the geological evolution of our planet. This movement is a natural and ongoing process that shapes our planet, creating mountains, valleys, and ocean basins over geological timescales. However, it also means that the potential for earthquakes is ever present, not just in seismically active regions like the Caribbean but also in areas that may seem geologically stable. This event should serve as a wake-up call, urging us to examine the potential for similar seismic events in other parts of the world, particularly near major fault lines that pose a significant risk to densely populated areas. We must learn from these events and prioritize earthquake preparedness to mitigate the potential devastation, ensuring that communities are better equipped to handle such natural disasters. Hidden beneath the majestic peaks of Denali, North America's highest mountain, lies a geological titan, the Denali Fault. This fault is not just a crack in the Earth's crust, it is a dynamic and powerful force that has shaped the landscape of Alaska for millions of years. This massive fault line stretches for hundreds of miles across Alaska, a testament to the immense forces that shape our planet. It is a living, breathing entity, constantly in motion, and its influence can be seen in the towering mountains and deep valleys that define the Alaskan wilderness. The Denali Fault is a strike-slip fault. This type of fault is characterized by the horizontal movement of the Earth's crust, where two blocks of crust slide past each other. This means that two sections of the Earth's crust slide past each other horizontally. The friction and pressure that build up along this fault line are immense, and when they are released, the result can be a powerful earthquake. The constant pressure and friction along this fault line make it a prime location for powerful earthquakes. These seismic events have the potential to reshape the landscape in an instant, creating new features and altering existing ones. The Denali Fault's history is etched in the very fabric of Alaska. The layers of rock and sediment tell a story of immense geological forces at work, shaping the land over eons. Over millions of years, the movement along this fault has sculpted the rugged landscape, pushing up mountains and carving out valleys. The breathtaking scenery of Alaska is a direct result of this relentless geological activity. The fault's activity is a constant reminder that this dynamic process is ongoing. Even today, the Denali Fault continues to shape the land, a testament to the ever-changing nature of our planet. The forces that shaped Alaska are still at work, and the potential for future earthquakes along the Denali Fault is a very real concern. These seismic events could have significant impacts on the region and beyond. The Denali Fault is not merely a local phenomenon, its influence extends far beyond the borders of Alaska, affecting the geological stability of the entire North American continent. Its reach extends far beyond the rugged Alaskan wilderness. The fault's activity can trigger seismic events that ripple across vast distances, impacting areas far removed from the fault itself. A major earthquake along this fault line could have far-reaching consequences, impacting not only Alaska, but also other parts of North America. The ripple effects of such an event could be felt across the continent, highlighting the interconnected nature of our planet's geological systems. Understanding the Denali Fault is not just a matter of regional concern, it's crucial for grasping the continental-scale impact of seismic events. By studying this fault, scientists can better predict and prepare for future earthquakes, potentially saving lives and minimizing damage. The Denali Fault stands as a stark reminder of the immense power that lies beneath our feet. It is a symbol of the dynamic and ever-changing nature of our planet, a force that can both create and destroy. Its presence underscores the importance of understanding and preparing for the potential consequences of earthquakes, not just in Alaska, but also in other seismically active regions around the world. By studying faults like Denali, we can gain valuable insights into the forces that shape our world and better prepare for the challenges they present. On November 3, 2002, the Denali Fault roared to life, shaking the very foundations of the Alaskan wilderness. A massive 7.9 magnitude earthquake ripped through the Alaskan wilderness, unleashing the pent-up energy along the fault line. The ground trembled violently, and the sheer force of the quake was felt far and wide. The earthquake was a stark demonstration of the Denali Fault's potential for destruction. Buildings crumbled, roads were torn apart, and the landscape was forever altered. It caused widespread damage across a vast area, ripping apart roads, triggering landslides, and shaking buildings to their core. The aftermath was a sobering reminder of nature's raw power. The 2002 earthquake provided a chilling glimpse into the power of the Denali Fault. The landscape bore the scars of the seismic event, a testament to the immense forces at play beneath the Earth's surface. The tremors were felt as far away as Seattle, over 1,500 miles from the epicenter. This widespread impact underscored the far-reaching consequences of such powerful seismic events. This event highlighted the interconnectedness of fault lines and the far-reaching impact of major earthquakes. The seismic waves traveled vast distances, affecting regions far removed from the epicenter. The 2002 Denali earthquake served as a wake-up call for scientists and engineers. It prompted a renewed focus on understanding seismic activity and improving our ability to predict and mitigate the effects of such events. It underscored the need for more robust infrastructure and disaster preparedness plans, particularly in areas located near major fault lines. The importance of building structures that can withstand such forces became more evident than ever. The event highlighted the importance of understanding the specific risks posed by different types of faults and the need for tailored mitigation strategies. Each fault line has its own characteristics, and a one-size-fits-all approach is not sufficient. The lessons learned from the 2002 Denali earthquake have been invaluable in improving building codes, strengthening infrastructure, and enhancing emergency response protocols. These measures are crucial in minimizing the impact of future seismic events. However, the event also highlighted the ongoing challenges in predicting and preparing for these powerful natural disasters. Despite advancements in technology and research, the unpredictability of earthquakes remains a significant hurdle. Many people live their daily lives unaware of the hidden dangers beneath their feet. The Earth's crust is constantly shifting, and while we may not feel it, these movements can lead to significant consequences. Scientists warn that the next big quake could strike at any time, catching us off guard. It's not a matter of if, but when. So, it's crucial to understand the risks and be prepared for what lies ahead. In the early 19th century, a series of powerful earthquakes shook the heartland of America. These quakes, centered in the New Madrid seismic zone, were so intense that they caused the Mississippi River to flow backward temporarily. The tremors were felt as far away as the East Coast, leaving a lasting impact on the region's landscape and its people. Today, scientists are closely monitoring the New Madrid seismic zone, using advanced technology to assess the ongoing risk. They have discovered that the fault lines in this area are still active, posing a significant threat to the surrounding communities. Understanding these risks is crucial for preparing and protecting the millions of people who live in the potential impact zone. Strengthening infrastructure is a key step in building resilience against future earthquakes. Engineers and city planners are working tirelessly to retrofit buildings, bridges and roads to withstand seismic activity. By investing in these improvements now, we can minimize damage and save lives when the next big quake strikes. Staying informed and ready is essential for everyone living in earthquake-prone areas. This means having an emergency plan in place, keeping a supply kit, and staying updated with the latest information from reliable sources. By taking these proactive steps, individuals and communities can better prepare for and respond to the challenges posed by earthquakes.